Hi everyone. Today in our lesson we're going to be starting Unit 7. Unit 7 is covering polygons and quadrilaterals eventually. Today we're going to be just covering some formulas that you'll need for polygons. You can download our notes on OMHS. The key is also posted there. And you're also welcome to check out the practice problems that come after the exit ticket on OMHS. Okay. So the first part of our notes, we're going to be filling in this table, and we're going to be using the interior angles sum. The sum of the degrees in any polygon is determined by the number of triangles that can be drawn within the polygon. And we're going to just fill in this table and find the pattern. So let's start with triangle, right? We know a triangle looks like this, and it has 3 sides. The number of triangles means how many triangles can you draw by connecting a vertex to the other vertices. Here, if I connect this vertex to this vertex, and then this vertex to this vertex, well, I've got 1 triangle. So we got 1 triangle. And we know the sum of interior angles. We learned that when you add the 3 interior angles of a triangle together, you always get 180. Now let's look at a quadrilateral. So for a quadrilateral, it has 4 sides, and pick 1 vertex and connect it to the other vertices. How many triangles do you have in there? 2. And we know that in a quadrilateral, the sum of the interior angles is 360. Let's look at the pentagon. Pick 1 vertex and connect it to the other vertices. How many triangles have we just created? We've just created 3 triangles. A pentagon has 5 sides. Have you figured out the pattern? I'll tell you that it has the sum of interior angles of a pentagon is 540. Maybe that will help figure out that pattern. Let's look at a hexagon. A hexagon has 6 sides. Pick 1 vertex and connect it to the other vertices. How many triangles are there? There's 4. So and sum of the interior angles is 720. Let's see if you can fill in the heptagon, octagon, nonagon, and decagon. A heptagon has 7 sides, an octagon has 8 sides, nonagon has 9, and a decagon has 10. You have to know the names of up to 10. After decagon, we'll just call it however many sides it has gone. So if it has like 11 sides, we would call it an 11gon. Or if it had 42 sides, we'd call it a 42gon. How many triangles can you create in each of these? Maybe you already see the pattern. You see the pattern for the sum of interior angles? See if you can fill those in, and then we'll fill them in together. So try that now. Right, so hopefully you saw the pattern where the number of triangles was just going up by 1. So when the number of sides went up by 1, the number of triangles went up by 1. And the sum of the interior angles was going up by 180 degrees. Now there's a way to actually relate the number of sides to your number of triangles. How would I get the number of triangles knowing the number of sides? Notice it's going down by 2, right? When there are 3 sides, there's 1 triangle. 4 sides, 2 triangles. So if you subtract 2 from the number of sides, that's going to tell you how many triangles I can create. And then knowing that, I'll be able to find the sum of interior angles. So the equation for that, the sum of your interior angles for any polygon is going to be 180 times the number of sides minus 2. That lowercase n is going to be the number of sides. And you can call this capital S for the sum of interior angles. So let's just go back to our chart for a moment. 180 times n minus 2. Okay, well, the number of sides minus 2, that's how we got the number of triangles. Number of sides minus 2. This was n. And the sum of interior angles, well, if I took that 1 and multiplied it by 180, I got 180. If you multiply 2 times 180, you get 360. If you multiply 3 times 180, 540, and so forth. So that sum of interior angles says take the number of triangles, or n minus 2, and multiply it by 180. And that will tell you the sum of the interior angles for any polygon. So your equation for the sum of interior angles is 180 times n minus 2. Now the interior angle of a regular polygon says that you have to have a regular polygon, and a regular polygon is one in which all of the sides are equal. So therefore all of the angles will be equal too. To find the measure of just one interior angle, you're going to take the sum of interior angles and divide it by the number of sides. Or I like to look at it this way, that 180 times n minus 2 divided by however many there are. Because that 180 times n minus 2 is representing the total amount, if you have all equal sized angles, then you can divide by however many angles there are, and that'll tell you the value of one of them. Okay, so it's very important to note that the second equation only works for regular polygons where they have equal sides and equal angles. This first one, this equation right here, the sum of interior angles, works for any polygon, regular or irregular. So let's look at some practice problems. Number 1 says find the sum of interior angles of a 15-gon. So there's an example of one that wasn't on our list. So a 15-gon has 15 sides. So the number of sides equals 15. And I like to highlight or underline or circle what I'm trying to find. I'm trying to find the sum of interior angles. So the equation for sum of interior angles was that 180 times n minus 2. Oh, it's a really sloppy parenthesis. Try that again. There we go. So the sum of your interior angles is 180 times n minus 2. So if n is 15, then the sum of the interior angles will be 180 times 15 minus 2. If I drew a 15-gon, which would be pretty challenging, I think. You could try it if you want. So if I draw a polygon with 15 sides, I would be able to make 13 triangles. And when I multiply that by 180, I get 2,340 degrees. Okay, because all the angles are measured in degrees, so our unit is technically in degrees. Go ahead and try number 2. Find the sum of interior angles of a 21-gon. Try that now. So you should have gotten 3,420 degrees. All right, number 3 says, what is the measure of each interior angle of a regular pentagon? So you have to know that a pentagon has 5 sides, because I could just call it a pentagon. Hopefully you know that already. So n equals 5. I'm trying to find the measure of each interior angle. So that's one interior angle. So you could say, oh, that's the sum of interior angles divided by the number of sides, or just use the equation for the sum of interior angles divided by the number of sides. Because this is a pentagon, I know that the sum of interior angles, or if I were to measure each interior angle and then add it up, that would be 180 times 5 minus 2. But all of those angles are the same size. So if I wanted to know the measure of just one of them, I would divide by however many angles there are. In this case, it's 5 because it's a pentagon. So in my calculator, I'm going to type 180 times 5 minus 2, or 180 times 3, get 540, and then divide that by 5. So our final answer here is 108 degrees. So this pentagon, or all regular pentagons, I guess, have the one interior angle that measures 108 degrees. I don't recommend memorizing the number of degrees in each angle for your polygons. Use the formula, because the formula works for all polygons, whether it's a pentagon or a 102-gon. So if you can remember the formula, you can use it for any polygon. I have had students try to memorize, oh, pentagons have 108 degree interior angle, quadrilaterals have a 90-degree interior angle. They try to memorize that, but instead of memorizing it, they're losing the equation, and then they get stuck when there's a problem thrown at them that they don't have memorized. So don't go memorizing these, just use the formula, and that's not hard to remember. And then that will work for any polygon. Go ahead and try it for an 18gon in number 4. What's the measure of each interior angle of a regular 18gon? Try that one. Do that now. All right, so you should have done 180 times 18 minus 2, and then taken that and divided it by 18. You should get 160 degrees. Okay. Now we also have exterior angles, and exterior angles are always supplementary to their adjacent interior angle. On these polygons that you see, we're going to find the measure of each exterior angle and then the sum of the exterior angles. So in this triangle, we know that 79 and its exterior angle will have to be supplementary because they're a linear pair. So I'll take 180 and subtract 79 and get 101. And then here, this exterior angle in 61 has to be 180, or they have to be supplementary, so they have to add to 180. So when I take 180 and subtract 61, I get 119. So this exterior angle is 119 degrees. The exterior angle out here will have to be supplementary to 40. So this exterior angle is 140 degrees. And now what it wants us to do is find the sum of the exterior angles. Add 101, 119, and 140. And we get 360 degrees. In this quadrilateral, clearly this is not a regular polygon because all the angles are different, but that's okay. We're going to find the measure of each exterior angle. Find what would be the measure of this outside angle, knowing that these two are a linear pair. So 180 minus 71. We get 109. 180 minus 124 tells me this exterior angle is 56. 180 minus 76 tells me this exterior angle is 104. And this exterior angle is 91. And now we're going to add those exterior angles together. 109, 56, 104, 91. And we get 360. I'd like you to try the pentagon and the hexagon. Find each exterior angle and then add those exterior angles together and tell me what is the sum of those exterior angles. So go ahead and do that now. Now that you have these 4 examples in front of you, what conclusion can you make about the sum of exterior angles for any polygon? What do you think? Did you say something along the lines of the sum of exterior angles of any polygon is 360 degrees? If you said that, you're right. Okay? If you didn't say that, go ahead and write that down. I'm curious to see if you said something different. But what we need to remember is the sum of exterior angles is 360 for any polygon. Makes it easy to remember. So let's practice that. What is the measure of each exterior angle of a regular hexagon? So let's think about it for a second. If they always have to add up to 360, then if I want to find the measure of just one, and they're all the same size because it's a regular hexagon, then I'll just divide by however many angles there are. Forgive my picture here, I'm going to do my best. Okay, let's say that I have a regular hexagon, meaning that all of the sides are the same and all of the angles are the same. Well, if I told you that these angles were all the same, let's say they're all x, and when I add them all up, that's the sum, I get 360. Well, then I would have x plus x plus x plus x plus x, 6x, and I would divide by 6 to find x. So that one interior angle is going to be 360 divided by 6, or the number of angles, number of sides that there were. So the number of sides here is 6 because it's a hexagon. I know that the sum of those exterior angles is 360. So I should have made these exterior angles. That was silly. Hopefully you still get the idea of what I was trying to do there. So if they all add up to 360, then one of them I can find by dividing by 6. So 60 degrees. Just got to fix my picture up here. Oops, where'd my eraser go? Right, so if all of these angles were the same size, that means all their exterior angles are the same size too. So this exterior angle should have been the X. There we go. So if all the exterior angles add up to 360 and they're all the same size, then we can just divide by however many there are. It's a little more challenging to draw one for number 6. It's a 24gon, which means it has 24 sides. I don't recommend drawing that picture. But it's a regular 24gon. Using the same idea we used on number 5, what's the measure of each exterior angle? Try it now. You should have gotten 15 degrees. The sum of those exterior angles is 360, and there's 24 of them. They're all the same size. So 360 divided by 24 is 15. Now, number 7 says, if the exterior angle of a regular polygon, meaning all the exterior angles are the same size, measures 12 degrees, how many sides does the polygon have? So n equals something that we don't know. But we know that all of them added together are going to add up to 360. I don't know how many there are, so I'll just call it n. So 360 divided by however many sides there are is one exterior angle. And one exterior angle is 12 degrees. Well, now we can solve for n. Personally, I like to put a 1 here so I can cross multiply. You don't have to do that. You can just multiply both sides by n and then divide by 12, whatever makes you happy. But I like to cross multiply. Divide both sides by 12. So this was a 30gon. Okay. In number 8, the measure of if the exterior angle of a regular polygon measures 40. So one exterior angle is 40. How many sides does this polygon have? Try this now. You should have gotten n equals 9. We've got a nonagon going on here. Now, sometimes students email me and ask me, what should I round to, or something like that. Here's an example of a question where you should never get a decimal. I cannot have a polygon with 9.7 sides. Polygons are going to have whole number sides. It has 3 sides, 4 sides, or so forth. Another answer that doesn't make sense is 2. You can't have a polygon with 2 sides. Remembering our definition of polygon from middle school, maybe even elementary school, a polygon is a closed figure with 3 or more sides. So if you get n equals 2, that shouldn't make any sense because I can't make a shape with just 2 sides. Okay, so if you're solving for the number of sides, you have to get a whole number. Otherwise, it just doesn't make sense. I'm not going to have a polygon with 3.5 sides or something like that. Okay, so we've talked about quite a few formulas here. Here's a little table to help you keep them all straight. The sum of interior angles of a polygon, okay, we called that S for sum, is 180 times n minus 2, the number of sides minus 2 times 180. One interior polygon of a regular polygon was the sum of the angles divided by the number of angles. Or I like to call that 180 times n minus 2 divided by n. Your sum of exterior angles will always be 360 degrees. The exterior angle of a regular polygon will be 360 divided by however many sides there are. And then we just used a formula like this, the number of sides. If you're looking for the number of sides of a polygon, you could say that's 360 divided by the measure of one exterior angle. Right? Because if 360 divided by n is the measure of one exterior angle, then when I multiply both sides by n and divide by the one exterior angle, or cross multiply, that's where that 360 divided by that one exterior angle comes from. Okay. This is not one that you really need to memorize because you can get it knowing this equation, but it can be helpful if you know the shortcut. A couple things to take note of. Whenever you're dividing by number of sides, the number of sides have to or those sides have to be the same measure, or they have to be a regular polygon. So if you're dividing by the number of sides to find the measure of one, you're saying that all of those sides or all of those angles are the same. So the interior angle of a regular polygon, the exterior angle of a regular polygon, those only work for regular polygons. Now the sum of interior angles and the sum of exterior angles, these work for any polygon, regular or irregular. So the next examples have just a mix of everything that we've just done. Okay, so example 1 says, what is the sum of the measures of the interior angles of a pentagon? I personally like to write away what n equals if I know it. It's a pentagon, so I know that n equals 5. Then I ask myself, well, what are they asking me? Are they asking me for the sum, or are they asking me for the measure of just 1? And it says, what is the sum? So you can go back to that table if you want, but the sum of interior angles is 180 times n minus 2. So this would be 180 times 5 minus 2. 180 times 3 is 540. So the sum of the interior angles of a pentagon is 540 degrees. Try number 2. What is the sum of the measures of the interior angles of a 27-gon? Try that one. Okay, so a 27-gon has 27 sides. So to find the sum of the interior angles, we're looking at the 180 times n minus 2. N is 27. So 180 times 27 minus 2. Type that in your calculator, you get 4,500. It's the sum of angles. So we have degrees as our unit. When you're writing your degree symbol, if you're writing it by hand, I caution you, make sure it looks like a degree symbol and not an extra 0. Sometimes I have students who put the degree symbol, and they keep doing work, and then they forget it was a degree symbol, and then all of a sudden they have 45,000 as their answer. So just be very careful. All right, in number 3, what is the measure of each interior angle of a regular octagon? Okay, well, an octagon has 8 sides, so I know that n equals 8. And it wants to know the measure of each interior angle. So not the sum, but the measure of each. So that's going to be the sum of the interior angles divided by the number of angles that there are. So that's 180 times 8 minus 2 divided by 8. Well, 8 minus 2 is 6. So I get 1,080, and then divide that by 8. So the measure of each interior angle of this regular octagon is 135 degrees. Go ahead and try number 4. Do that one now. So hopefully you got 162 degrees. One of the most common mistakes that I see students make on problems like this is they think to themselves, oh, 20 minus 2 is 18, and they accidentally put an 18 in the denominator. So be careful. Don't do that. All right. In number 5, it says 5 angles of a hexagon measure. It gives us the 5 angles. What is the measure of the 6th angle? Okay, so here's a problem that we haven't seen yet. So we have some hexagon where we have 119 degrees, 129 degrees, 104 degrees, 139 degrees, 95 degrees, and let's call it 6th angle X. Okay. Well, I know that the sum of the interior angles of any polygon is 180 times n minus 2. What is n in this case? N equals 6 because it's a hexagon. So 180 times 6 minus 2 is 720 degrees. So the sum of interior angles for this hexagon is 720 degrees. Okay, so now let's go back to that word sum. Sum means add. So if I add all of the angles together in this hexagon, I'm going to get 720. So let's do that. Let's add all of the angles in this hexagon together. That's the sum. Oops, I forgot X. Put it out here. The sum, I'm adding all 6 angles together, is the sum of the angles. Well, we just said the sum of the angles was 720. So there I have an equation. Combine all of my like terms, add the 119, the 129, 104, 139, and 95, and get 586. I can't combine that with the x since it's not a like term. I'll subtract 586 from both sides, and I get 134. So when you have an irregular polygon, you can add all of those angles together, and there's still going to be the sum of interior angles. So you can use the equation for sum of interior angles, add all the interior angles together, and know that they're actually representing the same thing. So they have to be equal. All right, I would put a star next to that one because we're going to be seeing problems like that a lot. In number 6, it says the sum of interior angles of a polygon is 1,620. How many sides does it have? So n equals, that's what we're looking for. The sum of the interior angles, well, we know that the sum of interior angles is n minus 2 times 180. The sum is 1,620. Now we can solve for n. You could solve this a couple ways. You could divide both sides by 180 and then add 2, or you can distribute the 180. That's what I'm going to do. I'm going to distribute 180. So 180n minus 360. Add 360 to both sides. And then divide by 180. So here's another case where n has to be a whole number because it's the number of sides. And a polygon has to have a whole number equals whole number of sides. Okay. So if it's ever asking you how many sides, that means solve for n. Try number 7. The sum of the interior angles in this polygon is 3,960. How many sides does this polygon have? Try this now. You should have gotten n equals 24. So it's 24 sides. If you want to check your work, you're welcome to go ahead and plug 24 back into the original formula, 180 times 24 minus 2. You should get 3,960. You will, but it's a good way to check. Number 8, what is the sum of the measures of the exterior angles of a nonagon? This should be really quick. The measures of the, let me try again. The sum of the measures of the exterior angles is always 360 degrees. Don't even care it's a nonagon because it's always 360, no matter what the polygon is. Okay. Number 9, what is the measure of each exterior angle of a regular 20gon? Well, I know that the sum, when I add all those exterior angles together, is going to be 360. And how many exterior angles are there? 20. They're all the same size. So 360 divided by 20 is 18 degrees. All right. If the exterior angle of a regular polygon measures 9 degrees, how many sides does the polygon have? Use the formulas that we've learned and try number 10. If you get it wrong, that's okay. Just try it. Do that now. If you got that it had 40 sides, you are correct. If not, double check your work with what you see on the board. Let me know if you have any questions about what you see. And number 11, if the interior angle of a regular polygon is 108 degrees, how many sides does the polygon have? So let's see. We know that the measure of one interior angle of a regular polygon is 180 times n minus 2 over n. And we don't know n, but we know that when we add all of those interior angles together and then divide by n, we're going to get, or when we add all those interior angles together, yeah, and then divide by n, we're going to get 108. So one interior angle is 108. So now we just have to solve for n. We could cross multiply. 108 times n is 108n. 180 times n minus 2 times 1, well, that's just 180 times n minus 2. Distribute your 180. Oh, I've run out of space. I'll come down here. Right, I'm going to subtract 180n from both sides. I get negative 72n equals negative 360. It's okay if you do that because we're now going to divide by negative 72. And a negative divided by negative is positive. So n equals 5. So now this was a tricky one because it was using the measure of one interior angle and asking us to find n. Okay. Maybe put a star next to this one too. If this was ever a multiple choice question, I honestly would probably just plug in the numbers and see which one makes my equation true. That would be a fast way to do it too. Let's look at number 12. Number 12 is an irregular polygon, and it says to find the value of x. Now my polygon is a quadrilateral. It has 4 sides, 4 angles, so n equals 4. The sum of interior angles is 180 times n minus 2. So the sum of these interior angles is 360. Sum means add them all together. So 79, 55, 110, and x. They're the sum of the interior angles. But the sum of the interior angles we just said was 360 for this quadrilateral. So we can set those equal. We'll combine our like terms, 244. So x plus 244 equals 360. Subtract 244 from both sides and we get 116 degrees. So x is 116. So the steps that I'm following for these irregular polygons is I'm finding the sum of the interior angles using the formula 180 times n minus 2. Then I'm adding all of the interior angles together and setting that equal to whatever the sum of the interior angles was. Try number 13. Do that now. Okay, so for number 13, we had 7 sides or 7 angles. Sometimes it's easier to count the angles than it is to count the sides. And because it had 7 sides, I can find the sum of interior angles, 180 times 7 minus 2. Well, 180 times 7 minus 2 is 900. So I know that these interior angles have to add up to 900. So I set up my equation where I'm adding all 7 interior angles together. Remember that little box is 90. So I add them all together and I'm combining my like terms. So I get x plus 806. And they have to add up to 900, the sum of interior angles. Subtract 806 from both sides, and there you get x equals 94. Sometimes it gets a little trickier when they add some algebra, but it's the same idea. Okay, so here n is, well, let's see, 1, 2, 3, 4, 5, 6, n equals 6. So if I do 180 times 6 minus 2, or 180 times 4, I get 720. So these interior angles have to add up to 720. So it gets really long, but not hard. We'll say 110 plus 8x minus 1 plus 5x plus 36 plus 116 plus 7x plus 19 plus 6x minus 2 equals 720. Okay, now we just have an equation to solve. Combine all your like terms. Add all your x's together, you get 26x. Add all of your non-x's together, you get 278. Subtract 278 from both sides, 442, and then divide both sides by 26. So x equals 17. And it was just solving for x, so we're done. In 15, same idea, but it's asking us to find the measure of angle B. So after we find x, we're just going to plug it in and find the measure of angle B. So go ahead and just try this process. However many sides there are, what's the sum of those interior angles? Add up those interior angles, make them equal to the sum of interior angles. Do a little algebra, solve for x, and plug it in to find B. Try that now. Okay, so n is 4. It has 4 sides, or 4 angles. So the sum of the interior angles is 180 times 4 minus 2, or 360. And when I add the 4 angles together, 8x plus 7, 5x plus 18, 10x plus 13. Now, even though that 10x plus 13 is written outside the polygon, that little arrow pointing to the interior angle means the font was just too big to fit there. Plus 14x minus 11. Those all have to add up to the sum of the interior angles, which in this case was 360. You combine all of your like terms, so you add all the x's together, you got 37x. Add all the not x's together, you got 27. Still equals 360. Subtracted the 27 from both sides, we got 333. And then divided both sides by 37, you got x equals 9. X equals 9 is beautiful, but it's not your answer. Your final answer is for the measure of angle B. So the measure of angle B is, well, let's see, B is 8x plus 7. So 8 times 9 plus 7. And you get 79. So our final answer is 79 degrees. All right, looking at number 16, let's solve for x. Well, first we have to figure out how many sides this thing has. You can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N equals 10. They're all the same sized sides, which means they have all the same sized angles. So this is a regular decagon, which means all of the angles are going to be 10x plus 4. So we know that 180 times n minus 2 all divided by n is the measure of one interior angle. And that's on our formula sheet. Well, we know that n equals 10. So we can say 180 times 10 minus 2 all over 10. Well, that's one interior angle. But one interior angle here is actually 10x plus 4. Now I have an equation with one variable, just x, and I can solve for it. I'm going to simplify this left-hand side a little bit. 180 times 8 divided by 10, you get 144. That's a little nicer to solve. Subtract 4 from both sides. Divide by 10. So here x equals 14. There are other ways to solve this, so if you thought of a different way, you might not be wrong. As long as you got 14 at the end, then we're good. If you want to check it out with me, like if you thought of a different way to do this, you just want to double check with me, you're welcome to email me and I'm happy to help. All right, let's look at number 17. Those are all exterior angles. What will all of the exterior angles add up to? You said 360, you're right. The sum of exterior angles is always 360. So you're just going to add your exterior angles together. 5x plus 4, 4x plus 9, 9x minus 6, 4x plus 1, and 7x plus 4. Those are all the exterior angles, and they will always add up to 360. Combine your like terms. See all the x's, you got 29 x's all together. And then when you combine the 4, the 9, negative 6, positive 1, positive 4, you get 12. Subtract 12 from both sides, 348, and divide by 29. So x equals 12. All right, so that was our introduction to the formulas needed for polygons. You will not be allowed to use a formula sheet on your quiz or your test. So I highly recommend putting these formulas on flashcards and practicing them with your learning coach, practice them on your own, practice them as you're doing practice problems. If you want that, again, here it is. The formulas, you've got really those first four are the four big ones. If you want to do the fifth one as bonus, you can, but you can always get that fifth one knowing the fourth one. Okay, so if you know these first four, you're golden. Put them on flashcards, practice them, and make sure you know them before you try a test or a quiz, because you will not be allowed to use a formula sheet on those assessments, and you definitely won't be allowed to use them on an SOL or something like that. They're not part of the official formula sheet. So go ahead and practice those. There are practice problems on OMHS for you. I'm okay if you use those formulas on the exit ticket for today, but not on a quiz and definitely not on a test. Have a great day, everybody.